Hi, welcome in this tutorial. Today we are going to explore the input module of the MEDomicsLab application. This module is part of the design layer and comprises several tools to assist you in performing basic manipulations on your CSV files. The MEDProfiles tool has its own videos, so we will not be presenting it in this tutorial. The merge tool functions as a visual representation of the Pandas Python library merge function. It allows you to merge datasets by defining various options. The first step is to select your dataset. Here, I've chosen a dataset containing a list of 40 patients and associated data. Next, I choose the column on which I want to merge my dataset with the other datasets. It is crucial that all datasets contain this column for successful merging. In this case, I choose to merge my dataset based on the column containing the patient's identifiers. Then, I can choose which columns from my dataset I want to include in my resulting dataset. By default, all the columns are selected. In this case, I leave the default options, but if I wish, I can deselect the columns I don't want to include in my resulting dataset. Now, we can set options for the second dataset. Let's choose data that includes the chosen merge column. In this case, my dataset contains data for 200 patients, including those from my first dataset. The merge option corresponds to the Pandas merge function options. Let's start by testing the inner option. Then, as with the first dataset, you can choose which columns from the second dataset you want to include in the resulting dataset. The merge column has to be selected. Here, I keep some additional columns to demonstrate the result. At the end, you can choose a name for your resulting dataset. Here, I name it merge_inner. Then I press the merge button. My dataset will be saved in the same location as my first dataset. If I open my generated dataset and compare it to my other datasets, I will observe that it contains the columns I've selected from my two datasets. Also, it contains fewer rows than my second dataset because all the patients that were not present in my first dataset were excluded from the inner merge, which keeps only the values from the merge column that are present in the two datasets. Now, if I want to keep all the rows from my two datasets, I can choose the outer merge option. Let's change this and keep all the other options as before. I named this dataset merge_outer. If I observe this resulting dataset, I can see that it contains as many rows as my second dataset, and some null values in the first dataset's columns for the patients that only had values in my second dataset. If my first dataset had patients that are not present in the second dataset, my outer merge dataset would also have contained this data and null values in the columns referring to the second dataset. Another merge option is left. This type of option will keep all the rows from the first dataset and will try to associate the rows from the second dataset based on the merge column. On the contrary, the right option will keep all the rows from the second dataset and will try to merge the first dataset's data based on the merge column. Finally, the merge tool offers the option to merge more than two datasets together. You can add as many datasets as you want by pressing the plus button and completing the form. The condition to merge datasets together is that they have a column in common. Here, I choose to add a third dataset, which contains the same patients as my second dataset, and I choose to keep a few columns for demonstration. I set all the merge types as inner, but you can choose others depending on what you want to do. If I open my dataset, I can observe that the data from my three datasets has been merged together, depending on the inner extraction, which kept only the patients from the subject_ID column that are present in all three datasets. The grouping/tagging tool will assist you in tagging the columns of your datasets to identify different types of data. This tool will aid in visualizing your data and will also prove beneficial in the learning module, where you can conduct machine learning with consideration for the data types defined by the tags. The first step is to select the dataset you want to tag. You can choose as many datasets as you want. Let's start with one. Then, you have to create your tags. If you press the plus button, predefined tags will appear. You can use them to tag your datasets or create new ones. Here I create two tags depending on the data I have in my selected dataset, image and note. Once my tags have been created, I can update, customize, or delete them. I can choose which color I want to give them by pressing their associated color in the tag list. I can choose if I want the name of the tag to be black or white by pressing their associated text button in the list. I can edit their name by pressing their associated edit button, and I can delete them by pressing the cross aligned with the tag I want to delete. Then, I will have to choose on which columns I want to apply which tags. I can choose many columns and many tags at the same time. The columns are displayed by datasets. Here, I start with a simple example. I choose to apply one tag on one column. So I selected my column in the column section and my tag in the tag section, and I pressed the green button. Then I answered yes to the question asking if I want to proceed with the tagging and yes to the question, do you want to overwrite the tags because I don't have any tags yet? Then, if I deploy my columns list, I will be able to see that my tag has been applied to my column. Let's proceed with another example using a different column and a different tag. Here again, I answer yes to the overwriting section because my selected column doesn't have a tag yet. Again, if I deploy my columns list, I will be able to see that my tag has been applied. Now, let's do an example of applying tags to multiple columns. As I have several datetime columns in my dataset, I create a tag date and select these columns to apply the date tag. If I deploy my columns list, I can see that my tag has been applied to all the columns I have selected. Now, what if I want to add a tag to a column that's already tagged? In this case, I can select my tagged column, choose the tag I want to add to it, and press the green button. To the question, do you want to overwrite the tags? I have to answer no, because if I do this, the tag already associated with my column will be removed, and that is not what I want. As always, I can check if my tags have been applied by deploying my columns list. Now, what if I want to apply several tags to a single column at the same time? Here, I just have to select my column, select all the tags I want to apply to it, and press the green button. And now, how can I remove tags from a column? I simply have to select my column, choose the tags I want to remain on the column, or select no tags if I want none on the column, press the green button, and answer yes to the question, do you want to overwrite the tags? That will erase the tags associated with the selected column before applying the newly selected tags. Here, as I didn't select any new tags to apply to my selected columns, the app only removed the previously associated tags from this column. Now, let's take an example with two datasets, just to show that it works exactly the same way as with one dataset. I select the columns from one or both datasets, choose the tags I want to apply, and press the green button. That's all. Finally, you can check the tags by expanding the columns list, but also by opening your tagged datasets in the app. The simple cleaning tool helps you deal with NaN values in your datasets either by columns, by rows, or both. The first step is to select the dataset you want to clean. Once selected, two tables will be displayed. The first one shows information about your dataset columns, and the second one about your dataset rows. For both tables, you have the identifiers of the columns or rows, the number of non-NaN values, and the percentage of non-NaN values in each column or row. Here, the dataset I've chosen as an example is the result of the outer merge in the first part of this video, which contains some null values. For each drop method, there is a slider associated with a percentage. This percentage determines when to delete columns or rows that contain the selected percentage or less of non-NaN values. Also, to help you determine the optimal percentage, you can sort each column of the table in ascending or descending order. Here, for example, I see that I have 3 columns containing 21.2% of non-NaN values, and the others don't contain NaN values. So, if I choose to clean my dataset by columns, I can indicate 22% to drop all rows that contain NaN values. By doing this, the involved columns will be displayed in the columns that will be dropped section, and the columns table will be updated by highlighting the involved columns in red. Also, the number of columns that will be dropped is displayed in red. Here, if I choose to click on the Drop Columns button, I will have two options. I can overwrite my existing dataset or create a new one. Here, I decide to create a new dataset with the default name, which is my dataset name with the _clean suffix. Then, I can observe my clean dataset in the app. I can do the same by rows with my original dataset. Here, if I sort by the percentage of non-NaN values, I see that all my rows containing NaN values contain 50% of NaN values. So, I select the percentage 50 in the row slider. Then, as with the columns, the rows that will be dropped are displayed in red and highlighted in the table. Looking at the displayed number of rows, I see that the majority of my dataset rows will be dropped. Finally, to apply my cleaning, I have two options. I may click on the Drop Rows button, as with the columns, or on the Create a Clean Copy button. The latter takes into account both the columns and rows to drop. Since I didn't select any columns, the result will be the same as if I click the Drop Rows button. As always, I can observe my resulting dataset in the app. Finally, you can choose to drop columns and rows at the same time. Select your percentages and click the Create a Clean Copy button. The Holdout Set Creation tool functions as a visual representation of the scikit-learn Python package's model selection train test split function. Additionally, you will have several options to assist you in creating your desired holdout set. Here, we are going to use this tool on a patient list. The CSV files contain some information, but we only need to focus on the subject ID, which are my patient identifiers and target columns. My file contains 200 rows, each corresponding to unique patients. So here I start by selecting my CSV file. Then I may choose to check the Shuffle option. This will shuffle the rows of my dataset before creating the holdout set. If I check this option, I may check the option Stratify, which will allow me to stratify my holdout set by columns. That means the columns I choose, which have to be categorical, will be represented as the same percentage in all my sets. So here, as I want to stratify my dataset by target, I choose the target column. Then, I will be able to choose the size of my holdout set as a percentage of my dataset by either using the slider or entering a percentage. Here I let the default percentage, which is 20. Next, I have to choose an option to deal with NaN values. The selected method will be applied by columns in the dataset before creating the holdout set. The drop method will drop rows containing NaN values, and the fill and fill methods will complete missing values by the previous or next values in the column. Here, as I don't have any NaN values in my dataset, I simply let the default method, which is drop. Then, I can choose a name for the folder that will contain my holdout set. I name it holdout_patients. Once all is done, I simply press the Create Holdout Set button. A folder will be created in the same location as my selected dataset and will contain a holdout set and a learning set. Finally, if I open my two generated sets, I can verify that they adhere to all the options I have set. The holdout set contains 40 rows, which is 20% of my dataset, and the learning set contains 160 rows, which is 80% of my dataset. Also, the proportion of the target has been preserved in the two sets. I had 50% of 0 in my dataset and 50% of 1, and that is also the case in my learning and holdout sets. The subset creation tool allows you to generate a subset from a data frame by applying specific filters. The first step to utilize this tool is to select the dataset from which you want to create a subset. Once selected, the dataset will be displayed in a table. Then, you have several options to filter your data frame. Let's start with the Global Search option. This one is located at the top right of your displayed dataset and allows you to filter your dataset by the rows containing the data you write in the global search input. It may be any entry from your keyboard. For example, here I type numbers matching elements from the subject_ID column. You can observe that as I am editing the search, the selection becomes smaller to match the filter. This option works with all the entries in the dataset. For example, here I type some dates supposed to match some elements in the start_date and end_date columns. The filtered date frame contains rows that match the filter in at least one of the two columns. If I want to remove my filters, I simply have to press the Clear button at the top left of my displayed dataset. Now, let's explore the other filter options. The subset creation tool allows you to filter your dataset by setting filters on every column you want. To begin, you can sort each column in ascending or descending order to observe your data. Then, you have a filter button at the right of each column header to set your filter options. The options you can set depend on the data type in the considered column. For example, here I have a binary column. I may choose to filter the rows to keep only the ones containing 1 in this column. As I am doing this, you can see the number of selected rows decreasing at the bottom left of my displayed dataset. This corresponds to the rows matching all the currently set filters. Let's set filters on other columns. Here I choose the start_date column, which contains dates. These are considered as string types for the filter options. Here, I'll start an example with the default rule, which is starts with. I set the beginning of a date matching some elements in the column and press Apply. My dataset has been filtered. Here, I can also add other rules by pressing the Add Rule button. I can select many types of rules designed for string data types. For example, I can set a contains rule. When I click Apply, the selected rows are updated. Something not shown in the video is that you can set the option Match All or Match Any in your columns filter. The Match All option, which is the default one, will only keep rows matching all the rules you've defined in your columns, whereas the Match Any option will keep the rows that match at least one option from your rules. Let's clear the filters for the last example. Here, my subject_ID is a column composed of numbers. You can see that the filters for this column are different from the ones in the start_date column. Here, as a demonstration, I just set a rule that keeps elements equal to the element I entered. As always, you have to click on the Apply button to apply your new rules to your dataset. Here again, you can add rules and change the option Match All to Match Any. Here's another example with another option. Well, finally, let's demonstrate how to create your subset from your filtered dataset. Once you've settled your filters, you simply have to enter a name and an extension for your file, and press the Create Subset from Filtered Rows button. Your subset will be saved at the same location as your original dataset. You can take a look at it by opening it in the app. The Feature Reduction tool enables the reduction of large datasets, such as the outputs from the extraction module. It consists of two tools, PCA, Principal Component Analysis, and Spearman Correlation. Let's begin with PCA. The dataset I use for the demonstration is the result of an image extraction using the DenseNet model and contains more than 700 columns. The initial step involves selecting your dataset from the list. Subsequently, you'll need to wait a few seconds for the application to load the dataset information before proceeding. After the data has been loaded, you will need to select the columns on which you wish to apply PCA. In this instance, I've chosen all the columns representing the dense features from the extraction. Once your selection is complete, press the Compute Eigenvalues button. Subsequently, the app will present a table indicating the explained variance of your resulting dataset based on the number of principal components you select. For instance, I have chosen to retain 10 principal components, signifying that my resulting dataset will encompass 53% of the information from the original dataset. Once you have selected your desired number of principal components by clicking on the corresponding row, you will be able to set a few options for your dataset. The option Merge Unselected Columns in the Result Dataset will integrate the columns you have excluded from the computation of eigenvalues into your resulting dataset. The column name prefix allows you to choose the prefix for your columns. You also have the option to name your result dataset. Here, I check the Merge option and set the column name prefix to Image. Once you have chosen all your options, simply press the Compute PCA Dataset button. Once your dataset has been computed, a success message will appear indicating where it has been saved. If I open it, I can see that the two columns not included in the PCA are present in the dataset, as I specified in the options. Also, the column name prefix has been included in the principal components columns. Now, let's do an example without merging the unselected columns and by modifying the column name prefix. Well, let's talk about the Spearman reduction tool. This tool allows you to see which columns in your dataset are most correlated to your target column. It helps you select the most relevant columns for prediction. The dataset I've chosen for this demonstration is the result of a time series extraction merged with a target column. It is essential for your dataset to contain a target column because without it, you won't be able to compute the correlations. The first step in applying the tool is to select your dataset. Then, similar to PCA, you will need to wait a few seconds for the app to load the dataset's information. Once the information has been loaded, you will need to select the columns for which you want to compute the correlation with the target. Here, I select all the columns containing computed information from time series. Then, you'll have to select your target column. Once that's done, you can press the Compute Correlations button. Once the correlations with the target have been computed, they will be displayed in a table in decreasing order of absolute correlation. Then, you will need to select the columns you want to keep in your resulting data frame. Here, I selected the 6 most correlated columns from the list. Finally, similar to PCA, you will have the option to set various preferences for your dataset. You can choose to merge the unselected columns from the first selector within your resulting dataset. Additionally, you can decide whether to retain the target column in your result dataset or not. Once again, you can choose a name for your dataset. Once all the options have been configured, click the Compute Spearman Dataset button. Once again, a success message will appear after the computation, indicating where your data has been saved. For this example, I chose to merge the unselected columns in the target and the result dataset. Let's do another example without merging any columns in the result dataset. Well, that's all for the input module tutorial. Don't hesitate to comment if you have questions. See you in the next tutorial.